Now we're going to look at a modified way to convert an alcohol to a halogen. So we learned that we can do this with acid, but in general, acid tends to be a pretty harsh reagent that we want to often avoid if possible. Also, if you look at this secondary alcohol right here, if we were to add an acid to this, and this were to go through an SN1 mechanism, putting a carbocation here, you would lose the stereochemical information in the starting material. So we have some specialized reagents to do this conversion. If you want to convert an OH to a Cl, you can use PCl3 or SOCl2. Both reagents will do this. If you want to convert an OH to a Br, you can use PBr3. So it's just the counterpart of PCl3. So a couple of key features with this reaction. It works with methyl, primary, and secondary alcohols, not tertiary. The mechanism by which this takes place, which we'll look at, is SN2, so tertiaries will not work here. The second is if the OH is at a chiral center, we get inversion. And that can potentially be useful when we're going to talk about how to take advantage of the stereochemistry in these reactions based on the reagent here in just a bit. So for this particular case, what we will expect is the PCl3 to convert the OH to a Cl, specifically at this carbon. But what's going to happen is you're going to get an inversion of the stereochemistry. So instead of an out group, it's now going to be a back group. And it will be a back Cl. Let's take a look at the mechanism for this. So we have our OH, which has lone pair electrons on the oxygen. And then I'm going to draw out the PCl3. Now, phosphorus can act as a nucleophile because it does have a lone pair here, but it can also act as an electrophile. It's kind of an interesting species. So what happens in the first step is the oxygen lone pair acts as a nucleophile, attacks the phosphorus, and we lose Cl as a leaving group. So now we end up with this oxygen that still has the proton attached, but it also has PCl2 attached. So what we've effectively done is turn that oxygen into a good leaving group. So now we have this attached. Now Cl- will act as a nucleophile. And because this is SN2, this attacks from the backside. And you'll lose your oxygen group as the leaving group. So now the products we get, we've added the Cl, and then the byproduct is this HOPCl2.